Welcome to my video that walks through the frequently made mistakes for assignment 2B. First and foremost, please make sure you document and format your code consistently. Otherwise, you're going to lose points when we do the final analysis and final grading. Let's go ahead and take a look at some of the leftover problems from the Unsynchronized Array class from previous assignments. There's a method called addAll that takes an array and is used to add that array at the end of the current array. We've tightened up the unit test so it detects the following mistake. You don't want to be using the toArray method here because that's going to make a copy of the array. And you don't actually have to make a copy just in order to be able to copy that copy. So instead, take a look at the array class and you'll see that there's actually another method that can be used to get a reference to the underlying array without actually making a copy of it. So that's a cleaner and more efficient way to do things. Here's another problem with the splitterator factor method from Unsynchronized Array. This implementation is passing the wrong parameter here as the third parameter to array splitterator. So please make sure that you fix that. And otherwise, you'll get some really strange results. Likewise, if you get really strange results from a unit test, don't just turn your solution in and hope for the best. Come to office hours, ask questions on Piazza, and make sure that you get the problems fixed. Let's go take a look at the Synchronized Array class. A number of people made some problems here where they were replicating the logic for unsynchronized array in synchronized array. And that's unnecessary. All you need to do instead of having all these extra fields is just define a single field, which is of type array E, where E is the element that's generic, and then initialize that to the appropriate unsynchronized array object in the various constructors. So once again, this constructor is overkill because you don't need to initialize all these fields. Just initialize the unsync array field, or whatever you happen to call it. Some other problems here. This is an example of where the person forgot to initialize the field, the unsync array field in the constructor, and then they're trying to do an array copy over something that's unfortunately not initialized. This code will crash. There are better ways to do this. There's more efficient ways, so make sure you do that. And I think that the unit test should warn you or mark these things as erroneous if you do them. Likewise, don't be passing unsynchronized array to the constructor that takes a collection because there's no relationship between an array and a collection. So this will also fail. As a general rule of thumb, try to stay away from using casts. They're almost always a sign that something is broken, just like in real life. If you have a cast on your arm, it's probably because it's broken. So avoid casts. Here's some problems with array splitterator, the try-split method in the array splitterator. This is the wrong way to compute the midpoint. Likewise, this is the wrong value to pass. That's the second parameter to the array splitterator constructor. So need to fix those things. Once again, the unit tests are your friend, and they'll tell you when you're doing things wrong. Here's yet another example of getting the midpoint wrong. What you need to do is you need to put some print statements in your code and then sit down and think carefully about what's the beginning, what's the end, and what the midpoint should be based on the current index. Let's take a look at a problem that comes with the collector, the array collector class. There's a couple of problems I saw here. First, get in the habit of using method references as opposed to lambda expressions. It's much more concise and to the point. And for the characteristics method, please go ahead and watch the video on non-concurrent collector API, where it shows you how to go ahead and create the appropriate type for characteristics. The approach here works, but it's sort of overkill and a little bit awkward and doesn't generalize very well. So the approach that's shown in that video is much cleaner. Let's now turn our attention to the Parallel Stream Crawler 1 class. You can see here that you should get in the habit of using expressions instead of statements where you don't need to use statements. So in particular, don't use an if-else statement, which ends up requiring the use of a statement block with the open curly brace and the closed curly brace down here, but instead use the question mark colon operator. And that will make it an expression. You can get rid of the extra curly braces and it'll be a lot cleaner. Conversely, here's an approach where you shouldn't use the question mark colon operator and instead use just a simple Boolean operator like logical and. And that's a cleaner way of doing things than trying to do code like this. Let's take a look at the process image, some process image problems from Parallel Stream Crawler 1. First, format your code consistently. When I say that, I mean make sure that you put the dots to line up like this. And then also make sure that you comment the code consistently so everything is commented at the beginning of the intermediate operation or the factory method or the terminal operation or whatever you have. So in this case, it was not consistent. It doesn't generalize, and so it just looks kind of wonky and weird. I also like to leave spaces between the various aggregate operations. I think it's just easier to read. This code has also got some bugs as well. It counts all the images, not just the ones that are being downloaded and transformed correctly. So if applied transform returns null, it's still being counted, which is wrong. And then finally, you don't need both filter and map. You only need one call to filter and then use a conditional expression there. Here's the process images method. You can see here there's a couple of issues. First, get in the habit of using method references instead of lambda expressions. So there's one case here that you could use a method reference for get or download image. Likewise, get in the habit of using objects non-null as a method reference instead of writing e not equal null as a lambda expression. And then finally, there's a couple of problems here. First, once again, get in the habit of using method references here. And secondly, map is the wrong method to use. It's the wrong intermediate operation to use here. And that's because map always returns the same number of elements in its output stream as it had in its input stream. But transform image returns a stream which can contain multiple transformed images for a given image. So you want to take a look at the videos we did a couple weeks ago about map and map to int, and then other videos in that general section of the course, and you'll see that there's a better method to use here, but not a better method, the right method to use here, which is not map. Here's some problems with transform image. First of all, this code is not consistently formatted. Again, it should look more like something like this, and it's also not documented, so it should be carefully commented to explain what everything is doing. And don't have your code run off the right-hand side of the screen. Those are more sort of syntactic style issues. And then there's also some important steps missing. Steps 3 and 4, applying the transform to the original image to produce a transformed image, and returning a stream of all non-null transformed images. So the code has to be expanded as well. Now we're looking again at transform image. This is also a case where the object's non-null method reference should be used instead of the result not equal null lambda expression. Let's now turn our attention to the Parallel Stream Crawler 2 class. So first of all, get in the habit of using fluent interfaces for the entire stream pipeline. You don't need to create a separate stream variable first. That's unnecessary here. And then secondly, something very important is missing. This is what the code used to look like. Something very important is missing here, so the code won't do anything useful. So that should be fixed. Here's the stream of tasks method. There's once again a problem where there's too many local variables. Instead, just use the fluent interface pipeline and the stream of factory method. This approach is kind of cool because it uses a stream builder, but that's overkill and it just confuses the issue and it gets away from using fluent interfaces as you ought to. Similar problem down here. Once again, we don't need to have an array list. In fact, that's kind of missing the whole point of using functional programming in streams. You don't want to have to allocate array lists directly. So instead, use the stream of factory method and allocate the elements appropriately. You don't need to do all this extra work. Here's the make images on page function, which is a factory method, and a number of people pass in the wrong parameter. You shouldn't be passing in page.getPageElements as URLs. There's a different parameter you should be passing in. So take a look at the comments and the spec and so on, and take a look at how the unit tests work, and you'll get a better idea of what's going on there. Here is make hyperlinks on page function. This code is too complicated. It's replicating code that's actually done in the, or should be done in the crawl hyperlinks on page method. So just create a function lambda that calls crawl hyperlinks on page, and don't bother repeating yourself here. That's unnecessary. Speaking of crawl hyperlinks on page, here's a problematic implementation of this method. You can see here that it's missing something important as parameter that's passed in to get page elements as strings. Also, don't use stream followed by parallel, or dot stream followed by dot parallel. Instead, use dot parallel stream. And dot parallel stream combines those things. And even though dot stream and dot parallel is not wrong, it looks weird and people would be very surprised to see that. There's also just some incorrect code here. In this particular case, the wrong parameter is being passed to perform crawl. It shouldn't be page to string. It instead should be something that depends on E, which is the element that we've got here. And the 1 is incorrect. It should be passing in the appropriate depth parameter, not just 1 unilaterally. That doesn't make any sense. And then the final frequently made mistake that I'm going to talk about is the transform image from Parallel Streams Crawler 2. There's a helper method that if you take a look at the sequential stream crawler and sequential loop crawler classes, you'll see that that gets used instead of writing all the code out here. This is way too complicated and cumbersome. And also, again, try to resist the urge to have things go off the right-hand side of the page. It gets very hard to read, especially when there's no comments. And so this code can be cleaned up. And then finally, you don't need to call collect here. Just return the result of the second call to filter, which outputs a stream. Filter returns a stream, and transform image returns a stream. So you don't need to collect it into a list and then turn that list right back into a stream. That's quite overkill and unnecessary. So that's essentially my walkthrough of the frequently made mistakes for assignment 2B. Please feel free to come to office hours. Please feel free to post questions on Piazza, and make sure that you run all your unit tests. And if you have any problems that show up, don't sit there and scratch your chin, but come and get help, because we're here to help you get a perfect score. And many people did get perfect scores, but many of those same people also need to improve the documentation and the commenting. So get in the habit of formatting and commenting and documenting your code consistently from the start, and then you won't have to do extra work towards the end of the assignment.